Hello there, and welcome to the Cosmic Lullaby Channel. Tonight, we drift into one of the most extraordinary mysteries in the universe: water. It seems so simple, doesn't it? A clear, quiet liquid that flows, freezes, and falls as gentle rain. Yet every single drop holds within it an ancient, silent story. The water in the glass beside you may have once rippled across Martian plains in a forgotten time, floated as a fine mist above an ancient, long-lost forest, or perhaps even glimmered in the tail of a comet long before our Earth was ever born. It is the most familiar substance on our planet, and still it remains one of the strangest. It is a quiet contradiction, a substance of immense power and immense gentleness. It bends light, defies gravity, and seems to remember the stars from which it came, carrying within itself the very spark of life. It is the universe's memory, held in a liquid form. If you enjoy these quiet journeys into the cosmos, I invite you to like, subscribe, or perhaps share a thought below. It helps other sleepy souls find their way to this quiet corner of the universe, one peaceful night at a time. But for now, there is nothing else to do. Just breathe. Allow your eyes to grow heavy and let yourself flow gently, softly into sleep. Let us begin. Every drop of water on Earth has been here for billions of years. Think of that for a moment. Nothing is ever lost. Water never truly disappears from our world. It only transforms, endlessly changing from vapor to liquid, from ice to mist, in a silent, continuous cycle through the ages. The very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. The very same molecules that once drifted in the breath of dinosaurs now fall from modern clouds and flow quietly through your veins. Each drop has been on an immense journey, a pilgrimage through oceans and glaciers, through the roots of ancient trees and the high, thin clouds, and through the bodies of countless living things that came before. Even the rain you hear softly tapping against your window tonight may once have been part of a primeval sea, shimmering under a younger sun. The water that makes up your very cells could have been frozen at the poles 1,000,000 years ago, or boiled from volcanic vents deep beneath the earliest oceans. On a planetary scale, almost no new water is ever created or destroyed. It is Earth's oldest traveler, eternally renewed and recycled. Every river, every tear, every single wave that breaks upon the shore carries within it the memory of deep time, whispering quiet stories of the world as it once was, long, long ago. The story begins even before our world existed. The hydrogen in every molecule of water was born in the Big Bang, before there were stars or planets, before there was even light as we know it. The universe was filled with a glowing, formless soup of particles. In those first few minutes after the Big Bang, protons and neutrons began to form hydrogen, the simplest and most ancient of all the elements. Every hydrogen atom that now dances inside a droplet of water has existed since those first cosmic instants, untouched by time itself. It is an immortal traveler. It has journeyed through glowing nebulae, been inside the heart of stars, and drifted through the cold, silent darkness of interstellar space. When it finally met oxygen, billions of years later, it formed the molecule that would cradle all living things. To drink a glass of water is to drink the first breath of the universe, the element that made the stars, and then, much, much later, made you. But the story needs two parts, and the oxygen in water came from a different, more fiery place. It came from dying stars. Oxygen did not exist when the universe began. It was forged much later, in the hearts of stars that lived and died long before our own sun was born. Inside their blazing cores, under unimaginable pressure, hydrogen and helium fused together, creating heavier elements like oxygen. When those ancient giant stars reached the end of their lives, they exploded as brilliant supernovae, scattering their oxygen-rich dust across the vastness of the cosmos. That stardust drifted and cooled, a ghostly fog of potential, eventually becoming part of the great clouds of material that formed our solar system. And when that cosmic oxygen met the ancient hydrogen, water was born. Every raindrop, every ocean wave, every misty breath you see on a cold morning is the echo of those long-vanished stars. You could say that water is the universe remembering itself. The ashes of creation, the remnants of cosmic fire, were transformed into something gentle, something that moves and glimmers with the quiet rhythm of life itself. The universe created a way to soothe itself, a way to be calm, and in that calmness, life found a home. Water exists in a state of constant, gentle transformation. In the right conditions, it can perform a quiet miracle, a trick of physics that feels like pure magic. It can exist as a solid, a liquid, and a gas, all at the very same time. Deep within scientific laboratories, and even in fleeting moments in the natural world, there are precise equilibrium points where this happens. Imagine it, high on a remote mountaintop, or inside the silent void of a vacuum chamber. Tiny ice crystals can melt and evaporate simultaneously. The molecules shift between these states so quickly that it is as if they refuse to choose just one form. It is a moment of perfect indecision, a state of being everything at once. This incredible ability makes water unique among the substances we encounter every day. It can move freely between worlds, becoming a cloud, a drop of rain, a flake of snow, or a plume of steam, all depending on the delicate dance of temperature and pressure. And in this strange, beautiful versatility lies the secret to life's persistence, the reason oceans can breathe, and rain can fall, and clouds can drift endlessly through an ever-changing sky. Scientists call this rare and perfect balance the triple point, a precise alignment where temperature and pressure meet in perfect harmony. At this exact condition, water truly exists as ice, liquid, and vapor all at once. It is not a transition or a trick of the light, but a true, stable coexistence of all three forms. In a laboratory, the sight is mesmerizing. A single droplet that shimmers as it freezes and evaporates at the same exact moment. On our planet, such conditions are incredibly rare, appearing only briefly in the delicate balance of high mountain air or at the edge of boiling springs. The triple point is a gentle reminder that water does not obey ordinary rules. A very calm, soft, and soothing world, with a quiet grace, forever fluid in its own identity. In that small, perfect window of physics, water reveals its deepest secret, that it is not bound to any one state, but belongs to them all at once. And its strangeness continues when it grows cold. Water expands when it freezes, and almost nothing else does. Most substances shrink and grow denser as they cool, pulling inwards. But water does the opposite. As it begins to freeze, its molecules arrange themselves into a beautiful, open crystalline pattern that takes up more space than the liquid around it. This is the work of the hydrogen bonds. The same forces that hold it together now push the molecules into a fixed, six-sided lattice, creating space, creating lightness. This strange expansion makes ice less dense, which allows it to float on water instead of sinking to the bottom. The consequences of this single elegant property are profound. If water behaved like any other material, lakes and oceans would freeze from the bottom up, trapping all life beneath ever-thickening layers of ice. Instead, the floating crust insulates the water below, protecting fish, plants, and entire ecosystems through the coldest winters. This quiet miracle of physics is the reason life on Earth survived through countless ice ages. Every frozen pond, every drifting iceberg is a living shield, built from geometry and temperature, a blanket of crystal protecting a sleeping world underneath. Imagine a world where this one rule was different. If ice sank, the great oceans would slowly freeze solid. Each winter, new layers of ice would form at the surface and then fall silently to the bottom, piling up on the last. Over time, the oceans would turn to solid, frozen snow, locking away the liquid water that all life depends on. Our planet would become a silent sphere of ice, glittering in the starlight, but completely barren. Fortunately, water's molecular design prevents this terrible fate. Because ice is less dense than liquid water, it rises instead of falling. The frozen layer at the top acts as insulation, keeping the depths just warm enough for life to continue, even through the harshest winters. Beneath the ice, fish still swim, currents still flow, and life endures. This single, delicate property of water is what keeps the earth alive, a narrow thread of chemistry that holds the difference between a frozen world and a living one. And even the act of freezing has its own strange rules. Under the right conditions, water can ignore the rules of temperature completely. When it is cooled very carefully and kept perfectly pure, it can remain a liquid even far below its normal freezing point. This state, called supercooling, happens because ice needs a starting point to form, a tiny impurity or a small disturbance to begin building its crystal lattice. In the absence of such a seed, the molecules just keep moving, holding together as a liquid in quiet defiance of all expectation. It is water in a state of pure suspense, holding its breath, waiting. The moment a single speck of dust or a tiny vibration touches it, the entire mass can freeze in an instant, turning solid in the blink of an eye. This fragile state exists naturally in high clouds, where droplets remain unfrozen until they collide with ice crystals or fall through turbulent air. It is a delicate reminder that the world around us is not rigid, but balanced on thresholds, always just one breath away from transformation. And the paradoxes don't end there. Hot water can sometimes freeze faster than cold. It sounds impossible, a riddle that turns logic on its head. Yet, under certain conditions, water that begins hot can indeed freeze more quickly than cooler water. This rare and puzzling phenomenon is known as the Mpemba effect, named after a Tanzanian student who first noticed it while making ice cream in the 1960s. A simple observation from a quiet moment that left scientists puzzled for decades. They have spent years trying to explain exactly why it happens, and the answer is still not completely understood. Part of the mystery lies in evaporation, which allows hot water to lose mass more quickly and thus cool more rapidly. Heat also changes the very structure of the hydrogen bonds, breaking apart tiny clusters of molecules that later make it easier for them to align into the perfect crystal structure of ice. It's as if the heat first creates a kind of chaos that allows order to emerge more quickly later on. Convection currents inside a container may also play a part, distributing temperature differently in warm water than in cold. The effect is delicate and inconsistent, a fleeting glimpse into water's hidden complexity. Yet it serves as a humbling reminder that even the most simple, familiar liquid still holds its secrets close. In every experiment, in every drop, water teaches us that nature never, ever runs out of surprises. Now, let us travel much farther from home, far from our kitchens and clouds, deep beneath the shimmering blue atmosphere of Neptune and Uranus. Here lies a form of water that could scarcely exist anywhere else in our solar system. Under pressures millions of times greater than those on Earth, and at temperatures hotter than the surface of the sun, water transforms into something truly alien, something called superionic ice. In this strange and extreme phase, the oxygen atoms form a rigid crystalline lattice, like in normal ice. But the hydrogen atoms move freely within it, flowing like a liquid. It creates a structure that behaves partly like a solid and partly like a liquid. A black, hot ice that even conducts electricity, glowing faintly from the immense heat trapped deep inside. Scientists believe this superionic layer is what explains the unusual and chaotic magnetic fields of these distant frozen worlds. Here on Earth, researchers have recreated the phenomenon for only the briefest of moments, using powerful lasers and diamond anvils to simulate that crushing pressure. It may be one of the most alien substances in existence, a crystalline sea that shines invisibly within the hearts of giant frozen planets. And in those same crushing depths, physics becomes poetry. Far below Neptune's calm turquoise clouds lies a world of unimaginable pressure and a strange kind of weather. In those deep, dark layers, methane molecules are squeezed so tightly that their carbon atoms break apart and bond together, forming crystals of pure diamond. These glittering fragments then fall slowly, endlessly, through layers of superionic ice and superheated liquid, forming what scientists poetically call diamond rain. Laboratory experiments on Earth have shown that such conditions can indeed turn methane into diamond under intense compression. If the same is happening on Neptune, its deep atmosphere could sparkle with falling gems, drifting slowly toward a dark ocean of water that never sees the light. A very calm, soft, and soothing, designed for relaxation and meditation. Some scientists believe those diamonds might even settle into vast, shimmering layers, or float like shining icebergs near the planet's core. It is a vision both surreal and scientific, a place where storms of diamonds may fall endlessly through seas that have never known a single ray of sunlight. From a storm of diamonds, let us return to a storm of something far softer. Let's come back to Earth and to the quiet fall of snow. Every single snowflake begins with a tiny grain of dust or salt floating in a cloud, a seed around which water vapor can condense and freeze. Because of the natural angle between the atoms in a water molecule, the growing ice crystal expands outward in 6 directions, creating a perfectly symmetrical hexagon. This is the fundamental rule, the blueprint from which all flakes are born. As the crystal drifts and tumbles through the sky, constantly changing humidity and temperature, sculpts its 6 arms into infinitely delicate and complex patterns. Some become long and needle-like, others grow wide and feathery like ferns. The air currents and the invisible layers of moisture in the atmosphere shape each one differently, yet all of them obey the same fundamental molecular geometry. The result is a crystalline masterpiece that embodies both perfect order and beautiful chance. No designer, no artist could ever reproduce the infinite variety of these tiny frozen mandalas. Each and every flake that lands gently on your sleeve is a unique work of molecular art, crafted by air, time, and temperature. A silent, fleeting record of the sky's chemistry, written in the language of ice. Every snowflake follows the same simple, 6-sided geometric rule. Yet, the unique and solitary path that each one takes through the clouds ensures that no two can ever be exactly alike. As they drift slowly downward, they move through invisible layers of air, each with a slightly different humidity and temperature. Each subtle shift in their environment alters how quickly the water vapor freezes onto their surfaces, changing the intricate pattern of their branches and ridges. Even if 2 snowflakes started their journey with the very same shape, their different paths through the atmosphere would make them diverge into beautifully unique forms. It is a journey of its own, a life story written in ice, lasting only a few moments. Under a microscope, their differences are endless and profound. From the thickness of each delicate arm to the minute angles between the crystal planes, the result is a natural, effortless infinity of design emerging from one simple molecule. Every snowfall is therefore both repetition and originality all at once, a silent dance of perfect symmetry and beautiful chance that never ever creates the same beauty twice. And if we could look even closer, beyond the crystal and into the liquid itself, we would find a world that is never still. In liquid water, the molecules exist in a state of constant, restless motion. They bond together through faint hydrogen attractions, but these bonds are incredibly fleeting, lasting for only the briefest of moments. Within a trillionth of a second, they break apart and reform elsewhere, causing each molecule to continuously exchange its partners in a silent, graceful ballet. This restless dance is what gives water many of its strange and wonderful properties, from its ability to store immense amounts of heat to its smooth, gentle flow. A very calm, soft, and soothing. If you could watch this at the atomic scale, the calm surface of a still lake would appear as a storm of ceaseless motion, a whirl of collisions and connections, forming and dissolving faster than thought itself. Each molecule is pulled between the forces of order and chaos, creating a liquid that is both cohesive and incredibly flexible at once. In every single droplet, an invisible choreography unfolds, endless and tireless, a quiet reminder that what appears perfectly still is, in truth, always, always alive with motion. Even when water appears to be completely motionless, its molecules are alive with energy. They rotate, twist, and vibrate in a constant rhythm, dictated by temperature and the subtle quantum tug of the forces between them. Every vibration gently stretches the tiny bonds between the hydrogen and oxygen atoms, then releases them like the soft hum of a cosmic string. These oscillations occur trillions of times each and every second, turning every single drop of water into a miniature symphony of silent motion. Even at the coldest temperatures, the molecules never truly stop moving. They retain a faint residual hum of energy called zero-point motion, a fundamental proof from physics that absolute stillness is impossible in our universe. It is this constant hidden activity that allows water to absorb and distribute heat, to dissolve so many substances, and to maintain the delicate chemistry of all life. Beneath the calm, reflective surface of a pond lies a hidden orchestra of vibrations, a microscopic rhythm that has played continuously since the first oceans shimmered beneath a young and glowing sky. To think of this hidden world is to be humbled by the sheer scale of it all. A single raindrop may seem small and ordinary, but within that one drop lies a population of molecules beyond all imagination. Roughly 10 sextillion molecules of water inhabit that tiny sphere, a number so vast it is greater than all the stars that fill our entire observable universe. Each one of those molecules is a perfectly balanced trio of atoms, held together by the most fundamental forces in nature. They collide constantly, binding and breaking with microscopic precision, creating the flowing dance that defines what it is to be a liquid. In that single drop, countless bonds form every moment, generating a motion so complex that it defies any easy description. It is staggering to realize that something so small can contain so much structure, so much complexity. Every single raindrop is a universe in miniature, full of motion, energy, and the intricate architecture of life's most essential and beautiful substance. The cosmos in a drop, a quiet reminder that the grandest designs are often mirrored in the smallest of things. And the mystery deepens even further, down into the strange and ghostly world of quantum mechanics, a world of ghosts and echoes, where the rules we know simply melt away. In this realm, water does things that seem impossible in the larger world we see. Its hydrogen atoms can occasionally slip right through energy barriers that should stop them completely, a phenomenon known as quantum tunneling. Instead of needing the energy to climb over a wall, the particle simply appears on the other side, guided by the quiet laws of probability rather than by force. This subtle and ghostly behavior affects how water interacts with biological molecules, influencing the delicate structure of DNA and the precise function of enzymes inside our living cells. In the cold emptiness of deep space, tunneling even helps water molecules to form in the coldest regions, where normal chemical reactions should be impossible. It is as though the molecule remembers paths that exist beyond our classical limits, moving through matter in ways that defy all logic. Within each and every droplet lies this quiet magic, a silent reminder that reality itself is less solid and far more mysterious than it appears to be. It is a substance of quiet defiance. For all its familiarity, water behaves unlike almost any other known substance. It should, by the laws of chemistry, boil at temperatures far below those we experience, and it should sink when it freezes, yet it does neither. Its capacity to hold heat is higher than expected, allowing it to absorb vast amounts of energy without a rapid change in temperature, which is what stabilizes our planet's climate. Scientists once assumed its properties could be predicted from simple molecular models, but water resists such simplicity. It refuses to be simple. A very calm, soft, and soothing, slow-paced with gentle intonation. Its hydrogen bonds shift and reorganize in ways that make it act both ordered and chaotic all at once. This strange and beautiful behavior is what protects living organisms and sculpts entire ecosystems. Without these quirks, Earth would be unrecognizable. Oceans would behave differently. Weather would be violent and uncontrolled, and life itself might never have had the chance to arise. What appears so simple in a glass is actually one of the most complex and beautifully balanced substances in all of nature. And even now, we are discovering new layers to its mystery. Recent discoveries suggest that liquid water is not just one uniform thing, but a constantly shifting mixture of two distinct molecular arrangements coexisting in the same drop. One form is dense and tightly packed, while the other is open, airy, and loosely bonded. These structures alternate and fluctuate within the same droplet over impossibly tiny scales of time and space. It is like two personalities in one soul, a dense, orderly self and a light, chaotic self, dancing together in fractions of a second. The delicate balance between them depends on temperature and pressure, and this duality may help to explain many of water's peculiar behaviors, especially when it is cooled near its freezing point. This dual personality means that even within one single glass of water, there are regions that act almost like two separate liquids, coexisting in perfect, unseen harmony. From this deep complexity, a simple beauty emerges on the surface. Water's surface is more than just a boundary between liquid and air. It is a flexible, invisible film, held together by the gentle embrace of its own molecules. A very calm, soft, and soothing voice, slow-paced with gentle intonation. Each molecule at the surface clings tightly to those beside it and beneath it, creating an elastic tension stronger than in almost any other common liquid. A skin of pure cohesion, strong enough to support life, soft enough to yield to a touch. This remarkable property allows water droplets to form into perfect spheres in space and enables tiny insects and specks of dust to rest delicately on its surface. It also helps water to climb upward through the narrow stems of plants, defying gravity, and to form the shimmering beads that roll so beautifully across leaves after a rain shower. Without this tension, dew would not sparkle on a spider's web, bubbles would not hold their round shape, and the delicate architecture of every raindrop would simply collapse. To small creatures like the water strider, the surface of a pond behaves almost like solid ground. They seem to glide effortlessly across the still water, moving with a silent precision. Each step they take creates a small, invisible depression in the water's surface, a dimple that pushes back gently and propels the insect forward. Their long, slender legs are covered in microscopic hairs that trap air and repel water, keeping them dry and buoyant. By adjusting how they press against this elastic surface, the striders generate thrust without ever breaking through. They can turn, jump, and even skate across moving currents, all without sinking. It is a masterpiece of adaptation, showing how evolution can turn the physics of tension into a new way of moving through the world. They exist in a world balanced between gravity and the quiet strength of water, a dance of buoyancy perfected over millions of years. And they are not alone. The diving bell spider is one of nature's strangest engineers. It lives almost its entire life underwater, yet it breathes air. To do this, it spins a beautiful silk web between the stems of plants below the surface and traps a shimmering bubble of air within it. The spider carries air down from above, clinging to tiny bubbles on the fine hairs of its abdomen, and releases them into its silk dome until it grows large enough to live inside. This structure works like a natural lung, allowing oxygen from the surrounding water to diffuse in, while carbon dioxide seeps out. It is a tiny, perfect underwater home, a small living example of how life can invent the most extraordinary ways to coexist with water's quiet, unchanging rules. Water's gentle nature hides a quiet power, an unmatched ability to dissolve other substances. Each of its molecules has a positive side and a negative side, giving it a property called polarity. This turns every molecule into a tiny, perfect magnet. When it encounters a solid, like a grain of salt or sugar, those opposing charges surround the particles and gently, patiently pull them apart. This silent, persistent process allows minerals, salts, and countless other compounds to disperse evenly through the liquid. Without this simple act of dissolution, there would be no nutrient flow in the soil, no oxygen exchange in our blood, and none of the delicate chemistry of life inside our cells. Water's dissolving power also shapes our landscapes, breaking down rock, carrying minerals from the mountains to the sea, and building new formations over immense spans of time. It is both a sculptor and a messenger, transferring matter from one place to another. In its patient, tireless way, water blurs the boundary between substance and motion, revealing that even the hardest materials on Earth will eventually yield to the gentlest and most persistent force of all. It is soft enough to touch, yet strong enough to shape worlds over millennia. Rivers and rain carve through entire mountains, dissolving minerals and carrying them away, grain by tiny grain. When water seeps into the smallest cracks in a rock and freezes, it expands with a quiet, irresistible force, breaking the stone apart from within. These tiny fractures, over ages, grow into canyons and vast hidden caves, sculpting the landscape with a patience that is beyond our comprehension. The Grand Canyon itself is a testament to this, a living record of water's steady, unending work. Each layer of exposed rock is like a page in a story written by ancient rivers. And even deep underground, unseen streams etch labyrinths through limestone, creating vast, silent caverns. The process is slow, quiet, and completely unstoppable. It proves that true power does not always roar or shake the ground. Sometimes it just flows gently, shaping stone with time instead of force, revealing that nature's greatest strength often lies in persistence and in calm. And yet, for all its power to connect and dissolve, in its purest form, it holds a kind of stillness. Contrary to popular belief, pure water is actually a very poor conductor of electricity. Its molecules are tightly bonded and contain no free charges to carry a current. It is only when salts, minerals, or other impurities dissolve into the liquid that it becomes a true conductor. In nature, water almost always contains these dissolved ions, these invisible passengers, which is why lightning, wires, and energy interact with it so dramatically. In laboratories, scientists can produce water so pure that it briefly acts as an insulator against electric flow, though it quickly absorbs contaminants from the air and its surroundings. This delicate balance between purity and conductivity is part of what makes water such a fascinating medium. It can act as both a pathway and a barrier, depending on what it carries within it. Each droplet is a vessel of potential, equally capable of transmitting energy or resisting it, depending on the invisible chemistry held inside. In a more subtle way, water seems to hold a memory of its own past, not in a conscious sense, but in its very structure. When water is heated or cooled, it changes not only in temperature, but in its molecular arrangement. The hydrogen bonds connecting its molecules shift, forming and dissolving in new configurations that can persist for a few brief moments, even after the temperature returns to equilibrium. This gives water a subtle trace of its past, a faint, fleeting echo of its motion, its turbulence, and its exposure to warmth or cold. It is an incredibly responsive substance, reacting to pressure, vibration, and light in ways few other materials can match. Each ripple, each movement of heat or sound leaves a momentary signature within it. Every single drop becomes a fleeting archive of the world that has just passed through it, a memory held for an instant and then released, forever changing and flowing. This is possible because of the energy held in its bonds. Within every drop, countless hydrogen bonds link one molecule to another. These faint attractions arise from the uneven distribution of electrical charge, connecting the slightly positive hydrogen of one molecule to the slightly negative oxygen of another. A very calm, soft, and soothing voice, slow-paced with gentle intonation, designed for relaxation and meditation. Each bond lasts for only a trillionth of a second before breaking and shifting elsewhere, creating an ever-changing network that stores and releases energy in tiny, invisible pulses. When these bonds form, they release a little warmth. When they break, they absorb it. This constant, rhythmic exchange is what allows water to regulate temperature so effectively, softening the extremes between heat and cold. The oceans hold vast reserves of energy because of this process, releasing it gradually to shape winds, currents, and the entire climate of our world. A microscopic dance of attraction and release that turns chaos into harmony, keeping the planet and every creature on it alive and in balance. A single molecule of water may appear simple, yet its precise shape defines nearly everything about the world we know. The oxygen atom holds its electrons more tightly than the two hydrogen atoms attached to it, creating a subtle separation of charge across the molecule. But the true secret is in its geometry. Instead of forming a straight line, the atoms connect at an angle of about 104.5 degrees, a slight, gentle bend. This specific angle is one of the most important numbers in the universe. If it were even slightly different, the world would be unrecognizable. This bent geometry makes one side of the molecule faintly negative and the other faintly positive, turning each one into a tiny, perfect magnet. And because of this, water molecules attract one another, forming the hydrogen bonds that make the liquid cohesive and alive with potential. From that one simple, elegant geometry arise all of its most extraordinary traits. The ability of ice to float, the surface tension that shapes every raindrop, and the power to dissolve countless other substances. Within that small, specific shape lies a kind of perfection born of pure balance. This unequal sharing of charge produces a subtle electrical imbalance called polarity. It makes one side of the molecule, the oxygen side, slightly negative, and the other side, the hydrogen side, slightly positive. This causes nearby molecules to constantly align and attract each other, forming a vast, ever-changing network that links every molecule in a shifting, shimmering web of bonds. Polarity is the secret of water's gentle grip. It allows water to cling to surfaces, to dissolve minerals, and to act as a living bridge between many different substances. It is what gives droplets their perfect rounded shape and lets waves flow across the ocean without separating. In every cloud and every sea, this gentle electrical structure is what holds the world together, a quiet force shaping entire planets. And this polarity lets water stick to itself and to you. This dual power of adhesion, sticking to other things, and cohesion, sticking to itself, lets raindrops form, allows rivers to climb through the soil, and lets sweat cling gently to the skin. It is what makes the surface of a puddle ripple when touched, and allows a single tear to roll smoothly down a cheek. In your own body, this very same property helps water to travel through the finest veins and tissues, carrying nutrients precisely where they are needed most. The way it holds together gives it both strength and softness at the very same time. It connects everything it touches, linking the living and the non-living worlds through attraction at the smallest, most fundamental scale. Life as we know it depends entirely on molecules that can dissolve, mix, and react, and water provides the perfect environment for that to happen. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. Its polarity allows it to gently separate charged particles, breaking them apart so that reactions can occur freely and safely inside our cells. It surrounds complex molecules like proteins and our own DNA, keeping them stable while still allowing them to move, change shape, and perform their work. Nutrients, minerals, and gases travel through it effortlessly, drawn by the same gentle electrical forces that bind the water molecules themselves together. Without this property, biological chemistry would grind to a halt. Cells would become rigid, and reactions would simply stop. Water's polarity turns it into a universal medium for transformation, a living stage that allows matter to rearrange itself into life. It is not simply a background substance. It is an active and essential participant in the act of creation itself. Your body is a vessel for this ancient water, but it is not distributed evenly. The human body is made mostly of water, yet it is not spread equally throughout. Your muscles, your blood, and your brain contain far more of it than your bones or fat. Inside your cells, water forms the vast majority of the environment where all chemical reactions occur. Outside the cells, it helps to transport nutrients and remove waste. Even within a single organ, different layers hold different concentrations of water depending on their function. This uneven distribution is what allows the body to remain flexible and efficient, balancing hydration precisely where it is needed most. Every heartbeat, every breath, and every small movement depends on the body's precise management of water across all its tissues. A flowing equilibrium that keeps life moving quietly from one moment to the next. And nowhere is this more true than in the seat of consciousness. The human brain is composed primarily of water, and that fluidity is what allows thought itself to occur. Tiny electrical impulses travel through vast networks of neurons, and each and every signal relies on ions that drift through water-filled channels. Without that fluid medium, the brain's delicate chemistry simply could not function. The balance of water inside and outside each neuron determines how easily these currents move, shaping our perception, our memory, and our mood. Even a slight dehydration can alter the brain's performance, slowing thought and blurring our focus. But water does more than just conduct electricity. It also cushions the brain within the skull, absorbing shocks and helping to regulate temperature. Every flicker of consciousness, every idea, every memory, and every dream depends on the quiet, constant presence of this liquid. The mind is not just housed in water, it is sustained by it, a sea of thought carried within a living tide. What we call blood is, in truth, a complex and living river. Its liquid portion, the plasma, is mostly water, carrying red and white cells, platelets, nutrients, and waste in constant silent motion. It is the body's great current, an internal ocean. The water's ability to dissolve salts, sugars, and gases allows it to perform its most vital task, transporting oxygen from the lungs to every distant tissue and carrying carbon dioxide back again. Water keeps this precious mixture thin enough to flow through the narrowest of capillaries, yet thick enough to carry everything the body needs. Without it, circulation would simply halt and cells would starve of energy. The very same properties that allow great rivers to carve through the land allow blood to move smoothly and silently through our arteries and veins. Without it, circulation would simply halt and cells would starve of energy. The very same properties that allow great rivers to carve through the land allow blood to move smoothly and silently through our arteries and veins. Every single heartbeat sends this water through a vast network that nourishes billions of living cells. Within each pulse, chemistry and physics work in perfect, quiet harmony, proving that life is not a static thing, but a continual, gentle flow, shaped and sustained by liquid balance. And in that internal river, the most sacred text of all is carried, the double helix of DNA, the molecule that carries all the instructions for life, exists in an environment that could not be more perfectly suited to it. Water surrounds the helix, stabilizing its delicate, spiraling shape, while still allowing it to twist, unwind, and copy itself with perfect fidelity. It is a guardian, a gentle protector. The molecule's outer edges attract water, while its precious inner bases, the letters of our code, hide away from it, creating a natural and perfect boundary that preserves its structure. This relationship is so precise that DNA simply could not function properly in any other liquid. Water's ability to dissolve and rearrange molecules makes the miracle of replication possible, guiding the endless copying that sustains every living organism. Each cell is a tiny, perfect droplet of this chemistry, where water acts as both a solvent and a protector. It cradles the code of life gently, allowing the past to be written into the future with every replication of its silent, spiraling script. And from that script, life's machinery is built. Proteins are the long, complex chains of amino acids that must fold into incredibly specific, three-dimensional shapes to function. In the absence of water, they would collapse incorrectly or simply fall apart. The reason for this lies in the delicate push and pull between water-loving and water-avoiding regions that exist along each and every chain. Water so gently guides these sections into their proper places, allowing the protein to take on its final, perfect form. It is like a form of molecular origami, with water as the quiet, invisible artist. Once folded, the same fluid stabilizes the protein, surrounding it like an invisible guardian. Without this watery environment, life's machinery would fail completely. Enzymes could not catalyze reactions, muscles could not contract, and our cells would lose their very structure. Each perfect fold is a silent dialogue between matter and moisture, a quiet negotiation where the liquid determines the final outcome. The simplicity of water hides its genius, for it is both a participant and the architect in the construction of every single living form. And this architecture is held together by the gentlest of forces. Every living cell is like a small, soft balloon filled with fluid. The pressure created by the water inside gives it structure and stability, allowing it to maintain its form even when surrounded by ever-changing environments. In plants, this internal pressure, called turgor, is what keeps stems upright and leaves expanded towards the sun. In animals, it supports the delicate membranes that define each cell's boundary. Without it, our cells would simply collapse or shrivel into nothing. This inner force also allows materials to move in and out, driving the constant flow of nutrients, gases, and signals. The same gentle push that shapes a leaf's curve or a vein's pulse is the quiet strength that keeps all of life intact. In every living thing, water acts as both scaffolding and support, its pressure maintaining form while still allowing the freedom of movement that defines what it is to be alive. The body is a world of water, and it has its own defenses. The brain and spinal cord, the very core of our being, float in a clear, silent fluid made mostly of water. This liquid, the cerebrospinal fluid, absorbs shock, cushions every small impact, and provides a stable, protected environment for our most delicate tissues. It is a world without weight, a place of perfect suspension, where our most precious self is held safe from the shocks of the outside world. Every movement of your head or body sends gentle, silent waves through this protective sea, preventing injury and maintaining a perfect chemical balance. The same water also delivers nutrients and removes waste, circulating continuously through hidden, quiet channels. It is water's ability to absorb force and distribute pressure that keeps the mind safe within its fragile shell, a silent guardian surrounding all of our thoughts and memories. And this protection extends to our senses. Though they seem so simple, both tears and saliva are intricate solutions where water plays the leading role. They are the body's own quiet rivers, one to cleanse our vision and one to begin the process of nourishment. In tears, water dissolves the salts and proteins that protect and heal the eyes, washing away dust and maintaining a perfect, clear moisture. In saliva, it blends with enzymes that begin digestion, softening food and helping the quiet act of speech. The high water content allows these fluids to spread easily and gently across delicate tissues, creating thin, uniform films that prevent dryness. Every droplet is a blend of biology and feeling, reflecting both a physical need and the quiet emotional chemistry of being alive. Water also carries heat through the human body far better than air can. It has an extraordinary ability to hold and transfer warmth, making it the perfect medium for maintaining our internal temperature. It is the body's thermostat, its great moderator, preventing the fires within from burning too hot and the cold from creeping in too deep. Blood, sweat, and all our internal fluids rely on this property to move warmth precisely where it is needed. When you exercise, the heat generated by your muscles is absorbed by water-rich tissues and carried quietly away, protecting your vital organs. And when the body overheats, it releases this moisture through glands in the skin. As the sweat evaporates, it draws energy away in the form of heat, cooling the surface. This simple, elegant process relies on the high heat capacity of water, which requires a significant amount of energy to change from a liquid to a vapor. It is a small, quiet miracle of physics, a transformation that carries discomfort away into the air, leaving behind only comfort and calm. This constant need for balance is why humans can survive for weeks without food, but only a few short days without water. The body depends on it for nearly every single function. While our fat and muscle can provide stored energy for weeks, there is no such reserve for hydration. Every breath, every drop of sweat, and every single exhale releases this precious moisture. When that loss exceeds its replacement, our organs begin to fail. It is a humbling reminder that life exists only as long as this liquid balance does. With each breath you take, your body releases a little of its moisture into the air. On a cold day, you can see this invisible process, a small cloud of your own making, as mist escapes into the atmosphere. This continuous cycle connects each living being to the planet's atmosphere, contributing to the humidity and the weather patterns of the world. And this release continues even as you sleep. During rest, the body continues to lose moisture through breathing and evaporation from the skin. Even in perfect stillness, the exchange continues, as if the body dreams in water. Every night is a reminder that our existence is never separate from the great, gentle flow of the world. The water leaves us and rises to the sky, where it gathers in forms that seem to defy gravity. The average cloud, though it appears weightless and soft, is made of billions of tiny droplets and can hold hundreds of tons of liquid water spread across a vast and silent volume. They are oceans held in suspension, floating rivers, waiting for the moment when gravity finally calls them home again. A cloud seems so soft and weightless, drifting gently across the afternoon sky. In truth, it is a vast and heavy collection of tiny, individual droplets, each one made of pure liquid water. A single cloud can contain hundreds of tons of water, yet it floats, because the droplets themselves are so incredibly small that gravity has little effect on them. They are suspended in a perfect, delicate balance. Rising warm air from the ground supports them, creating an invisible equilibrium between the upward lift of the air and the downward pull of the earth. Each droplet is less than the width of a single human hair, light enough to be carried for miles and miles on the wind. It is a beautiful paradox, immense weight held aloft by near nothingness, a floating ocean that is lighter than air. And these clouds are just the visible part of a much larger, invisible system. Among all the gases that warm our planet, the most powerful and the most plentiful is simple water vapor. It forms naturally and silently through evaporation from oceans, lakes, and even the breath of living organisms. This invisible vapor traps heat radiating from the Earth's surface, holding it in the lower atmosphere and keeping our planet warm enough for life to flourish. Without it, the world would be a frozen, silent desert. Yet it does not merely trap heat, it also regulates it. Clouds form when this vapor condenses, and those white clouds reflect sunlight back into space, gently cooling the planet below. In this way, water acts as both a warm blanket and a bright mirror. The delicate balance between these two effects is what determines our weather patterns and the stability of our climate. Every droplet that evaporates becomes part of this vast planetary thermal cycle, rising invisibly before returning again as rain. Nearly all of Earth's water rests in the vast, deep embrace of the oceans. They cover more than 2/3 of our planet's surface and contain a staggering 97% of its total volume. The remaining tiny fraction exists as ice, rivers, lakes, underground aquifers, and in the atmosphere above us. The oceans are the great regulators of all life and climate. They absorb the sun's heat and move it around the world through immense silent currents, shaping our winds, our storms, and our rainfall. To stand at the edge of the sea is to face the source of nearly everything that is alive. Of all the water on Earth, only a tiny, precious portion is fresh and available for us to drink. A very calm, soft, and soothing voice, slow-paced with gentle intonation, designed for relaxation and meditation. Less than 3% is free of salt, and most of that is locked away, frozen in glaciers and the great polar ice caps. The remaining portion flows through our rivers and lakes and sleeps in underground reserves, forming the lifeblood of all land-based ecosystems. Every drop that flows from a mountain spring or falls as rain, carries with it the quiet weight of scarcity. The cycle that renews it is ancient, driven by sunlight and gravity. Yet it is also fragile and easily thrown out of balance. To drink a clean glass of fresh water is to experience one of the rarest and most precious materials on our planet. The majority of Earth's fresh water does not flow on the surface where we can see it, but instead hides deep beneath the ground or within frozen realms. Far below the surface, beneath immense layers of rock and pressure, liquid water still exists. It moves through ancient pores and cracks in the Earth's crust, heated by the planet's own inner warmth. And beneath the miles-thick ice of Antarctica lie vast, hidden lakes of liquid water. They remain unfrozen, not because of heat from above, but because of the immense pressure from the ice and the geothermal warmth seeping up from the Earth far below. Some of these lakes have been sealed off for millions of years, isolated from the world since long before humans existed. They are silent time capsules, holding secrets of an older Earth, still alive beneath its frozen shield. And this idea of hidden oceans is not limited to our world. In the outer solar system, far from the warmth of the sun, several moons conceal vast oceans beneath their frozen crusts. Jupiter's moon Europa, beneath its gleaming, cracked shell of ice, hides an immense global ocean. Though smaller than our own moon, it may contain twice the volume of all the water found on Earth. And near Saturn, the small bright moon Enceladus shoots fountains of water from its frozen surface. Cracks near its south pole act like vents, spraying plumes of vapor and ice hundreds of miles into space. It is an entire world, exhaling its ocean into the void. Each icy moon whispers of unseen depths, reminding us that life's potential may not depend on sunlight at all, but on the quiet, patient persistence of liquid water waiting in the dark. And so the search for water expands, far beyond our own solar system. Astronomers studying distant stars have detected the faint, telltale traces of water vapor surrounding planets light years away from us. Using immense space telescopes, they analyze the starlight as it passes through a planet's atmosphere. And in that light, they can identify the spectral signature of water, a faint pattern of absorption that reveals its presence. It is like seeing a shadow of a ghost, a whisper of home from across an unimaginable distance. These observations have found vapor on worlds that range from scorching gas giants to smaller, rocky planets orbiting cooler stars. The discovery has changed how we think about the universe, showing that water is not unique to Earth, but is common throughout the galaxy. Every detection expands the quiet dream of finding another habitable world, a place where the same molecules that fall as rain here may be drifting as mist on a planet hundreds of light years away, whispering the same quiet chemistry that once gave rise to life in our own small corner of the cosmos. And it began long before the planets were even born. Between the stars, in the regions that appear to us as dark and empty, immense clouds of gas and dust drift slowly and silently through space. Within these great, cold nebulae, molecules form on the surfaces of tiny, icy grains, and among them is water. Though it is extremely diffuse, these clouds contain enough vapor to fill all of Earth's oceans many times over. When new stars ignite within these nurseries, the surrounding heat releases that frozen water into space, seeding the material that will later form planets and comets. The universe itself is a generator of life's ingredients. Even in the coldest, darkest places, the chemistry of creation continues. And from these clouds, messengers are born. Comets are frozen time capsules, beautiful relics from the birth of the solar system that still carry the original water from its formation. Made of ice, rock, and dust, they travel on long, graceful paths that bring them close to the sun and then send them back out into the deep, silent cold. As they warm, the ice within them turns to vapor, forming the glowing tails that stretch for millions of miles behind them. Each pass through the inner solar system releases a little of their ancient cargo into space, scattering water and organic molecules wherever they go. Comets are both messengers and midwives, carrying the ancient chemistry of creation through the void, reminding us that even in darkness, the seeds of oceans and life can drift silently between the stars. Many scientists now believe that a large portion of Earth's water arrived this way, delivered by colliding comets and asteroids. When our Earth was young, its surface was molten and dry, a world of fire and rock, constantly bombarded by debris from space. Over millions of years, some of those impacts delivered icy material from comets and water-bearing minerals from asteroids. As the planet finally cooled, the vapor they released condensed into liquid, forming the very first oceans. Each violent impact carried more than destruction. It carried the potential for calm. It carried renewal. The water that now fills our seas and rivers may once have been locked inside these drifting stones, waiting for gravity and time to bring it home. Some of the meteorites that still fall to Earth today hold minerals that once trapped water deep within their crystal structures. Each stone becomes a record of that ancient process that shaped the solar system, a message from the past. And our world was not the only recipient of this gift. The red planet Mars bears countless scars of flowing water from its distant past. dry riverbeds, ancient deltas, and deep valleys carve its surface, suggesting that gentle rains once fell there. Minerals found by our rovers show patterns that can only form in the presence of liquid water. And its polar ice caps still hold vast reserves of frozen material. For perhaps hundreds of millions of years, Mars may have had lakes and shallow seas, protected by a thicker atmosphere that kept them from evaporating away. But over time, the planet lost most of its air to space, and with it, most of its water. The evidence paints a picture of a world that was once warmer, wetter, and perhaps, just perhaps, alive. Venus, our planet's strange and shrouded neighbor, now a world of crushing heat and acidic clouds, may once have been far more Earth-like. It is a ghostly twin, a warning written in the orbits of the solar system. Early in its history, it likely possessed vast, shimmering oceans of liquid water. But as the young sun grew brighter and stronger, the surface of Venus warmed. The increased heat caused more and more water to evaporate, and the vapor, a powerful greenhouse gas, trapped even more energy in the atmosphere, creating a runaway feedback loop. The planet grew hotter, and the heat made it hotter still. Eventually, the oceans boiled away entirely, and the intense ultraviolet radiation from the sun broke apart the remaining water molecules in the upper atmosphere, allowing the light hydrogen atoms to escape forever into space. What remained was a thick, toxic atmosphere of carbon dioxide and clouds of sulfuric acid. Venus became a story of what happens when a world's delicate balance is lost. Yet, even today, in its high, swirling clouds, faint traces of water vapor still linger, faint ghosts of the seas that once covered its face, whispering of a world that could have been a sister to our own. And our own planet is not entirely immune to this slow loss. Earth is quietly, constantly leaking its water into the void. High above the clouds, at the very edge of space, powerful ultraviolet sunlight splits water vapor into its component parts, hydrogen and oxygen. The light hydrogen atoms are so small and energetic that some of them gain enough velocity to slip past Earth's gravity and drift away forever into space. Each escaping atom is a tiny, invisible thread pulled from an ocean that has existed for billions of years. The loss is minuscule, far too slow for us to ever notice. Yet over geological time, it adds up. Our planet's strong magnetic field and thick atmosphere protect most of its precious supply. But the process never, ever stops. Every second of every day, thousands of hydrogen atoms escape, carrying with them the faint memory of the seas and storms far below. Space quietly drinks from our oceans, one invisible sip at a time, a silent reminder that even the most abundant elements are not truly eternal. And the oceans that remain are not static. They are always changing. They are slowly, almost imperceptibly, growing saltier over time. The saltiness of the sea is not a fixed thing. It increases very gradually as rain, rivers, and streams dissolve minerals from the rocks on land and carry them down into the oceans. Once there, most of those salts stay behind when water evaporates to form clouds, leaving the sea just a little more concentrated with each and every cycle. This process has been unfolding for hundreds of millions of years. And although the change is incredibly slow, it shapes the chemistry of all marine life, the formation of shells, and even the movement of the great ocean currents. The ocean is always balancing itself, never truly still. The salt you can taste in a single drop of seawater is ancient, the residue of mountains and rivers that have long since vanished, dissolved into the ever-changing equilibrium of the world's deep blue heart. Every single grain of salt in the sea began its journey locked in stone. The salt that gives the ocean its sharp, clean flavor was once part of a mountain. Rainfall, made slightly acidic by the carbon dioxide it absorbs from the air, seeps into rock and soil, and over long ages it dissolves tiny amounts of minerals like sodium and chloride. Rivers then carry those dissolved particles on their long journey to the sea, where they accumulate over eons. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. The ocean never truly gets rid of them, because the process of evaporation removes only pure water vapor, leaving the salts behind. What remains in the sea grows slowly more saline as the ages pass. In this way, every crystal of sea salt tells a geological story, a quiet record of rain meeting rock and a mountain surrendering to time. The taste of seawater is the memory of entire continents breaking down, grain by patient grain. Each wave that crashes against the shore carries with it the ghost of stone, a reminder that the land and the sea are not opposites, but partners in an eternal, silent conversation of erosion and renewal. At great depths, where the pressure is immense and the light of the sun has never reached, water begins to behave differently. It becomes a different substance, something more powerful. It can dissolve minerals and metals far beyond what would be possible at the surface. In the crushing, silent darkness of the deep ocean, or within the deep cracks in the Earth's crust, superheated water becomes a powerful and hungry solvent. It leaches elements directly from the hot rock of the planet's mantle, creating strange and potent chemical mixtures that vent upward through deep fissures in the seafloor. When this superheated fluid finally meets the near-freezing water of the deep, the minerals precipitate out, forming shimmering, otherworldly deposits of metal and crystal on the ocean floor. These natural reactions, happening in total darkness, shape the chemistry of the entire ocean and influence entire ecosystems. Water becomes both a sculptor and a messenger, carrying the signature of the deep earth upward, and returning to the surface bearing the quiet whispers of heat, of stone, and of hidden, powerful transformation. Imagine sinking into this world. Down and down, past the last flickers of sunlight, into a realm of absolute blackness and unimaginable pressure. Here, along the spreading ridges of the ocean floor and near volcanic boundaries, cracks in the Earth's crust open to release powerful jets of water heated by the magma far below. And though the surrounding sea is near freezing, these vents expel a fluid that can exceed hundreds of degrees in temperature. Yet it remains a liquid, held together by the immense crushing pressure of the ocean above it. As it gushes out, this water carries a thick plume of dissolved metals and sulfur compounds that quickly cool and solidify in the cold sea, building towering, ghostly chimneys of black or white mineral deposits. They are like the smokestacks of a hidden geothermal world. And around these impossible vents, something truly miraculous happens. Entire ecosystems flourish, unlike any others on Earth, thriving in total darkness without a single ray of sunlight. Here, bacteria feed directly on the chemicals in the vent water, using chemosynthesis instead of photosynthesis to create energy. These tiny organisms form the base of a unique food web that supports strange tube worms with blood-red plumes, pale crabs, and ghostly fish. Each vent is a world unto itself, a glowing chemical oasis in the deep, cold dark. The water that escapes there is not lifeless heat, but a cradle of chemistry, bridging the fiery interior of the planet with the cold, silent expanse of the ocean above. It is so strange and so full of life that many scientists now believe the very first living organisms on our planet may have emerged not on the sunlit surface, but here in the deep sea near these hydrothermal vents. Here, the mineral-rich water mixes with the cold seawater, creating the steep chemical gradients and the abundance of energy needed for life's first spark. The porous walls of the vent chimneys could have provided the perfect natural structures to trap and concentrate simple molecules, allowing carbon compounds to combine into more complex and beautiful forms. Within those microscopic, sheltered environments, life's earliest chemistry may have taken hold, driven by geothermal heat and mineral energy instead of sunlight. In these dark, pressurized realms, life could have begun as a series of gentle, quiet reactions within the pores of a rock, slowly learning how to store and use energy, slowly learning how to live. But water's strangeness is not just found in the extremes of heat, but also in the quiet, gentle embrace of the cold. Most substances grow denser and heavier as they cool, but water reaches its greatest density at a temperature just above its freezing point, at around 4 degrees Celsius. This unique and fortunate behavior means that as lakes and ponds begin to chill in the winter, the coldest water, the water that is about to turn to ice, actually rises to the surface instead of sinking. The slightly warmer, denser water settles at the bottom, creating a protected, insulated layer where life can survive through the long, cold winter, safe beneath a thin, floating shield of ice. That subtle shift, just a few degrees wide, is enough to decide whether a lake remains alive or falls into a silent, frozen stillness. When winter descends and the air grows bitterly cold, the surfaces of lakes begin to freeze. Yet beneath that growing sheet of ice, liquid water remains, protected by one of nature's most fortunate and beautiful coincidences. Because water is densest slightly above freezing, the coldest layer, the layer that is about to turn to ice, stays on top. And as it freezes, it floats, forming a protective, insulating barrier that shields the depths below from the harsh air above it. Fish, plants, and countless microorganisms can then continue their slow, quiet existence under this sheltering lid. A realm of muted colors and slow heartbeats, waiting for spring. If water behaved like other substances, the entire lake would freeze from the bottom to the top, extinguishing all life each and every winter. Instead, it rests in a perfect equilibrium, conserving the faint warmth of the earth while still allowing gas to exchange through small cracks and holes in the ice. Each frozen surface hides an entire secret living world beneath, a quiet, hidden miracle of physics and geometry that keeps the planet breathing through the long, deep cold. And this dance with temperature drives a larger seasonal rhythm. In temperate climates, lakes experience a yearly ritual known as turnover. During the long days of summer, the warm, sunlit water floats above the cooler, denser layers far below, creating a stable and calm separation. But as autumn arrives and chills the surface, the top layer grows denser and sinks, causing the layers to mix and circulate oxygen and vital nutrients from the top of the lake all the way to the bottom. In the spring, the process repeats itself when the ice finally melts and the strong winds of the new season stir the water once again. This beautiful, silent cycle is what nourishes all aquatic life, preventing stagnation and distributing food and oxygen evenly throughout the water. Without it, the deep waters would become depleted and lifeless, unable to support complex ecosystems. turnover transforms a still lake into a living system that breathes with the seasons. It connects the surface winds with the underwater currents, the birds in the air with the fish in the depths. Each rotation of the planet brings this hidden, gentle stirring, a quiet renewal that has unfolded for thousands and thousands of years. From the quiet breath of a lake, we turn to the great breath of the ocean. When we watch the waves rolling steadily toward the shore, it appears as though the water itself is traveling great distances across the sea. But in truth, it is the energy that moves forward, while the water mostly circles in place. Each water molecule follows a small orbital path, rising and falling as the wave's energy passes through it. This elegant and efficient mechanism allows the energy from winds and distant storms to travel across entire oceans. The shape and the rhythm of the waves tell the stories of distant winds, of invisible storms, and of the slow, steady turning of the planet itself. Their ceaseless motion connects continents and climates, sculpting our coasts and guiding the migration of ancient life. To watch a wave is to witness pure transfer, a pulse of energy rippling through the water, echoing the heartbeat of the world itself, steady, patient, and eternal. Far out at sea, some waves can journey for thousands of miles before ever touching a shore. These are called swells, great rolling movements of energy set in motion by powerful storms that happened perhaps days ago and half a world away. Their ceaseless motion connects continents and climates, sculpting our coasts and guiding the migration of ancient life. To watch a wave is to witness pure transfer, a pulse of energy rippling through the water, echoing the heartbeat of the world itself, steady, patient, and eternal. Far out at sea, some waves can journey for thousands of miles before ever touching a shore. These are called swells, great rolling movements of energy set in motion by powerful storms that happened perhaps days ago and half a world away. Once created, they travel freely, guided only by wind and gravity, crossing entire ocean basins in a perfect, hypnotic rhythm. Their shapes remain smooth and regular as they carry the deep memory of the storm that gave them life. When they finally meet shallow water near a coast, the lower part of the wave slows down, while the top continues to move forward, rising higher and higher until it finally curls and breaks. They are the long breath of the planet, silent messengers from weather systems we will never see, traveling endlessly until they release their stored energy on the shores of a distant land. And this is only the surface of the ocean's movement. A far greater, slower rhythm is at play. The tides are the daily pulse of all of Earth's water, the perpetual motion of water pulled by celestial hands that never rest and never lose their strength. Every coastline on Earth feels the gentle, rhythmic pull of the moon, and, to a lesser extent, the distant sun. Their combined gravity draws the oceans into vast, silent bulges that move around the world each and every day. The result is the hypnotic rise and fall of the tides, a planetary heartbeat that shapes our coastlines, guides the lives of marine creatures, and has influenced human civilization for thousands of years. Tides fill and empty our estuaries. They carry vital nutrients into the shallows, and they create the vast shimmering mudflats that feed entire ecosystems. This gravitational attraction between the Earth and the Moon stretches the oceans into two of these great bulges, one facing the Moon and another on the opposite side of the planet. The result is the hypnotic rise and fall of the tides, a planetary heartbeat that shapes our coastlines, guides the lives of marine creatures, and has influenced human civilization for thousands of years. Tides fill and empty our estuaries. They carry vital nutrients into the shallows, and they create the vast shimmering mudflats that feed entire ecosystems. This gravitational attraction between the Earth and the Moon stretches the oceans into two of these great bulges, one facing the Moon and another on the opposite side of the planet. As our world rotates on its axis, different regions pass through these high water zones, creating the two high tides we experience each day. The Moon's pull is strong enough to move entire seas, yet so gentle that the motion feels almost like a whisper. The Sun also adds its own influence to this dance. It either amplifies the effect during the full and new moons, creating the highest spring tides, or it softens the effect during the quarter moons, creating the gentler neap tides. This constant celestial interplay shapes the daily rhythm of every coast and the lives of all the creatures that depend on them. And the tug of the Moon does more than just move the water. It also, ever so slightly, slows the Earth's rotation over immense periods of time, gradually lengthening our days. Every tide is a trace of that ancient, invisible bond, the silent, beautiful evidence that our oceans dance in perfect step with a companion world that glows quietly above them in the night sky. But the pull of gravity that moves the oceans also stretches the solid Earth itself. The very rocks beneath our feet rise and fall by small amounts each day, creating subtle land tides that can shift the ground by several centimeters. It is a movement so small, so slow, it is completely imperceptible to us. Even the atmosphere responds to this pull, forming slight, invisible bulges of air pressure that travel silently around the globe, in perfect time with the Moon's orbit. The entire planet, it seems, moves gently to the same cosmic rhythm, as if it is breathing in unison with the sea. What we see as the waves and tides on the surface are only part of a much deeper more profound pulse, a gravitational music that plays through the air, the water, and the very stone of our world, uniting every layer of the earth in a quiet, celestial harmony. And this rhythm is part of a much larger, endless cycle. Every single molecule of water is part of an eternal journey that connects the clouds, the rivers, the oceans, and all living beings. Sunlight lifts vapor from the sea, forming clouds that drift across the sky. When they cool, the vapor condenses and falls again as rain, feeding the great rivers and the quiet lakes, seeping deep into the soil and returning eventually once more to the ocean. The very same molecules can move through the roots of plants, the bodies of animals, and even the air that we breathe, before rising again as a fine, invisible mist. This cycle has been operating for billions of years, maintaining a perfect, life-giving balance between the land and the sea. It is the Earth's eternal heartbeat, the invisible thread that ties every living thing to the motion of the sky above and the great dark depths below. The water that runs through your body at this very moment has existed since the beginning of the world. It once drifted through high, thin clouds, froze in ancient ice, and cascaded down waterfalls long, long before you were ever born. Within your veins, ancient hydrogen and oxygen atoms are reunited, continuing their endless circulation through time. The molecules that now sustain your very life may once have passed through the leaves of prehistoric trees, or fallen as gentle rain upon the backs of dinosaurs. And when you exhale or sweat, they return to the air, ready to become part of the cycle all over again. There is no new water. There is only transformation. Each breath and every heartbeat carries the same ancient essence that has moved through oceans and skies for billions upon billions of years. You are a part of the planet's great silent flow, a living vessel through which the story of water continues, calm and constant from age to age. When rain falls upon the land, not every drop reaches the ocean quickly. Some embark on a much longer, quieter journey. Some will sink deep into the ground, joining the ancient aquifers that flow slowly and silently in the darkness beneath the surface. Others may freeze into the great glaciers, where they can remain trapped for millennia, suspended in time before melting once again. A single drop might linger in a calm lake for decades, or be drawn up through the roots of a great tree, passing through its leaves before evaporating back into the clouds, ready to begin its journey once more. The travels of water are never straightforward. They are wandering and patient.
It rests for ages in forests, rivers, and deep within ancient stones. Scientists studying the faint isotopic signatures in groundwater have traced some molecules that began their long descent during the last ice age and are only now, today, emerging from a hidden spring. Every raindrop is a traveler through deep time, following its own winding, secret path. At the poles and on the highest, most remote mountains, layers upon layers of snow are compressed into deep, ancient ice that traps tiny bubbles of air, specks of dust, and countless water molecules for hundreds or even thousands of years.
These vast, frozen archives preserve detailed, perfect records of our planet's past climates, storing the memory of ancient storms, forgotten volcanic eruptions, and the subtle changes in the atmosphere from long ago. Scientists can extract long ice cores to study these records, reading the layers like the pages of a history book written by the Earth itself. Some of the water that is sealed deep within this ice has not melted since long before human civilization ever began. When the sunlight of a warmer age finally touches it again, the molecules are released to continue their endless journey through the atmosphere and the sea. The frozen stillness of a glacier hides a slow, patient rhythm, a heartbeat that moves only when the world itself grows warmer. Each melting drop is a messenger from the past, whispering of ages when the earth was younger, colder, and full of a quiet, waiting light. And as it moves, it gives life. In every ecosystem, water acts as the great carrier, moving the nutrients of the earth from one place to another. Rain seeps gently through the soil, dissolving minerals that feed the roots of trees and the smallest of plants. Rivers gather organic matter from decaying leaves and transport it downstream, where it nourishes the fish and the reeds. Even in the driest deserts, the rare and occasional rains trigger sudden, beautiful bursts of life as dormant seeds awaken and hidden microorganisms flourish. The movement of water connects all environments, turning small, local cycles into vast, global systems. Every living thing depends on its ability to flow and transport. Without it, nutrients would remain trapped, and our ecosystems would stagnate and die. A single droplet that falls on a forest floor may one day reach the distant sea, enriched with the carbon and minerals it gathered on its long, winding journey. And from above, the clouds are not merely fleeting shapes in the sky. They are the builders and sculptors of the earth. Within them, microscopic particles of dust or salt act as the seeds around which water vapor can condense. When the droplets grow heavy enough, they fall as rain, feeding the rivers that carve our valleys, fill our great lakes, and shape the edges of our continents. Over millions of years, this gentle, persistent rainfall sculpts the very face of the planet, wearing down entire mountains and carrying their remains, grain by grain, to the sea.
It creates our fertile plains, it nourishes our vast forests, and it fills the deep aquifers that have supported civilizations for centuries. The raindrops that fall on a single hillside today may one day become the soil that grows a forest centuries from now. And this water reflects the world back to us. When we gaze at a calm lake or the deep sea, we often think it looks blue because it is simply mirroring the sky above. But that is only half of the truth. Pure water actually has a color of its own. It absorbs the red parts of the sunlight more effectively than it absorbs the blue parts, allowing the cooler blue tones to scatter back to our eyes. In shallow water, this effect is faint and subtle, but as the depth increases, the hue deepens into a rich, luminous azure. The color of water is a quiet dialogue between reflection and absorption, between the light that comes from above and the nature of the molecules deep below.
To look into the water is to see both the heavens and the very material of life intertwined, a beautiful image of our earth as seen through its own luminous blue skin. It is the planet's own inner light, shining out from the depths. Pure water can even glow faintly on its own. Under ultraviolet illumination, perfectly clean water emits a soft, almost invisible luminescence, a quiet, internal light. This faint glow comes from the gentle interaction between energetic photons and the molecular bonds within the liquid itself. It is a silent reaction at the quantum level, a reminder that even still water holds the memory of energy, the faint afterglow of the universe's first great illumination. And sometimes life borrows this magic. In warm coastal waters, countless microscopic organisms called dinoflagellates perform a nightly miracle. When they are disturbed by the movement of a wave or a passing fish, they release beautiful flashes of blue-green light that shimmer across the surface of the sea. Each tiny spark is a chemical reaction within their cells, turning energy into bioluminescence. The combined effect turns the waves into liquid starlight, glowing trails that follow every ripple. Beaches that host such displays seem to breathe with light, as if the sea itself were dreaming. And the ocean is not a silent place. Sound travels differently through water. Because its molecules are packed so closely together, vibrations pass between them much more efficiently, allowing sound to move nearly 4 times faster than it does through the air. This makes the underwater world a place of surprising noise, filled with the clicks, groans, and songs of life that can carry for hundreds of miles. Whales and dolphins rely on this clarity to navigate and to communicate across vast, lonely distances. The songs of the great whales can travel for thousands of miles beneath the surface. Low-frequency sounds move through deep channels of water with remarkable efficiency, allowing these enormous creatures to remain in contact across entire oceans. Each species has its own complex language of pulses, moans, and beautiful melodies. A blue whale's call can be louder than any machine built by humans, yet it is musical and haunting. The ocean becomes their stage, its density and depth shaping every single note. Listening to them is like hearing the voice of the planet itself, vast and ancient and resonant. And the deeper we descend into this ocean, the more the weight of the water presses down. For every 10 meters of depth, the pressure increases by the equivalent of the Earth's entire atmosphere at sea level. At the very bottom of the Mariana Trench, the deepest point on our planet, the pressure exceeds 1,000 times that of the surface. A solid sphere of steel would collapse instantly under such an immense weight. Yet, even here, in the total darkness and crushing force, delicate organisms still survive. Microbes flourish at the very bottom of the ocean, feeding on the chemical compounds that drift down from the world above or seep from the Earth's crust below. Their resilience offers us clues about how life could exist on other worlds, in hidden oceans where the sunlight never ever reaches. The trench floor, though silent and dark, is alive with an invisible, quiet purpose. Proof that the boundaries we imagine for life are far narrower than the reach of life itself. And so, we see that water is the only substance found naturally as a solid, a liquid, and a gas on our planet. From the ice of the poles, to the liquid of the oceans, to the vapor in the air we breathe, its constant, gentle cycle is what makes our world live. And the oceans we see are only part of the story. Far beneath our feet, deep within the rocky mantle of the earth, lies an enormous, hidden reservoir of water, bound within the very minerals of the planet. There may be more water locked in the Earth's mantle than in all of the oceans combined. And beyond our world, astronomers have detected a colossal cloud of water vapor surrounding a distant quasar, a cloud that contains thousands of times more water than all of Earth's oceans. The cosmos, it seems, has been saturated with water since its earliest days. So remember, the atoms that form a single sip of water were forged in ancient cosmic fires. The hydrogen was born in the first few seconds after the universe began. And the oxygen came from the hearts of dying stars that exploded, scattering their precious elements across space. Each glass you raise is a reunion of cosmic history. To drink water is to taste the memory of the stars. Somewhere, perhaps not far from where you are now, a single drop of water falls. It may strike the surface of a pond, or the curve of a leaf, or the open sea. And from that one sound, small, round, and vanishing almost as it begins, the story continues. It is the pulse in every tide,
the shimmer in every storm, and the deep, deep calm that follows. So, as you rest now, imagine yourself floating within that endless, gentle cycle. The motion slows, the surface smooths, the breath deepens.
Let your eyes grow heavy, and let the deep, quiet waters cradle your thoughts. Slow, weightless, and free. Good night.